Okay, so let's unfreeze this because Liza put up her results. Okay. The first thing, do you all want to know how to be excellent story opportunity solvers? I don't call them word problems, by the way. Why don't I call them word problems? Because it automatically sets you up to think you're going to have a problem, right? So story opportunities. Here's a story opportunity. The first thing, and this is the piece that algebra students never want to do, but it's the key. If you cannot define what you're trying to find, you're sort of already lost. So the first thing you should do after you read the problem is look at what the question is asking you. That's what you need to solve for. That's your variable. So what was the camera's price before the reduction? Use any variable you want. X tends to be the standard. So Liza said X is the price. The only thing I would do now, and those of you who have had Sandy Goki know this, you put in your unit after it, dollars. I would just put the dollar symbol. X equals the price. Oh, she already wrote it in words. See? Very good. Did you have Sandy, Liza? Yep, there you go. Good habits established. X is the price in dollars before the reduction. Okay, so she's establishing what she needs to find. Okay, that's step one. Sometimes you'll have more than one variable expression. You might even have more than one variable. Okay. The second thing you need to establish is what I call a what equals a what. What? What equals what? If you can't establish what equals a what, then you can't establish an equation to solve. So Liza then said, $276 represents what? That represents the reduced price. How do you get the reduced price? You take 40% off of your original price. So really, what this 0.6x represents, I would have made a little room back at step one, and I would have written this, 0.6x, because I'm using that expression in my equation. I want to say to myself, I know what that means. 60% of x in words would be what? The price what? What would that represent? After the price in dollars of the digital camera, after what? After the reduction. All right, so now at step one, I have clearly established what I need to know. I understand the problem, and I'm showing myself and my teacher, and then I'm establishing a good habit for the rest of the problems I'm about to do today. So X is the price, the original price of the camera, the digital camera. 0.6x is the price of the camera after the reduction. How did I get 0.6x? What did you all do in your brain to get that 0.6x? What did you do? You took the original price. Now notice the original price X has a 1 in front of it. It says I'm taking 100% of that cost. That's what the 1 means, 100% of the cost of the camera. And what did you do to get that 0.6x? A lot of you didn't show it. Yep. Yep. If you subtract 0.4, you won't be able to simplify that. So what did you really subtract? 0.4 what? 0.4x, because you're taking 40% of the price of the original price. And that's what gives you your 0.6x. Okay? Your what equals what says the price after the reduction. If you can say it, you can write it. There it is. The price after the reduction is equal to 276. So to solve this, you divide both sides by 0.6. That's where your calculator comes in. Now, I just want to make a point about this, and I did this for a lot of you on your first quiz, question number 1. I didn't take off for this. X is a variable. The answer to X is a number. This is not $460. It's 460. When you then put your answer into a sentence or into that little space on the side of your quiz, if you now want to establish a unit, it's fine. But X itself is just the number. So now you say the original price of the camera, the digital camera. Always answer your things with a sentence, was, and now you can attach your unit, $460. So in the iceberg problem, the tip of the iceberg, the volume that you solved for was 2. X was 2 in that problem. When you write your answer, that's when you put on the cubic kilometers. Okay. So that's how we do this. So again, the strategies, what were the strategies? Identifying all of the unknown quantities in your story opportunity with a variable or variables and describe them in words. Your description has to be a numeric quantity with units. So if you've had Sandy for 095, you've got that established. I know you do. Then you create a what is equal to what. In your mind, you say what's equal to what. You can write it out in words, and then you use your algebra to create your expression. So let's try these strategies with some more problems here. Okay, so let's take a look at the second one. Let's begin by looking at the following graph. I got this from your book. It's a bar graph. And what it does is it shows the average yearly earnings in the United States for people with a college education by the final degree earned. So this first bar, if you read the height, represents the average yearly earnings if you have a bachelor's degree. The second bar represents the average yearly earnings if you have a master's, a doctorate, and then professional degree. So what would a professional degree be like? What do you think? Oh yeah, it could be a professor, but unfortunately we don't make that much, well, at least not at a community college. Certain, like doctors, lawyers, those types of professionals, even though like a doctorate for a lawyer, they could fall in here, it is a professional degree. Okay, so as you can see here that in general, your salary goes up with the more education you have. I don't know what's going to happen with today's economy to these bar graphs, because we now know that there's lots of people out there on the market with degrees, bachelor's and master's, and they can't find jobs. So we'll see what happens to this over time. Hopefully oh, the railroad, huh? Maybe that's what I'll do when I retire. Or I will become like Elysium, if anyone has seen Elysium. I just saw that last night. I thought it was great. Anyway, the average yearly salary of an American. So here's the story. Your job is to wind your way through this story, find what the story's asking you to solve for. Sometimes it's more than one thing. That's your goal. Then describe it in words, and then find what is equal to what. Okay, those are the series of strategies. The first thing you need to do is you need to read the problem. So everybody read the problem. You don't need to hear me say it out loud. So take a minute and read the problem. Okay, so does anybody recognize this next line? Where do I begin to tell the story? I guess my age is showing. Anybody ever heard of the movie Love Story? No, really? Oh, I guess I am really ancient. All right. There was a song in Love Story that started with this line. Where do I begin to tell the story? La, 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 la. Look it up. It's actually kind of a nice little tune. So where do I begin to tell this story? What's my first step in solving this? Well, let's take a look. Next page. All right. So we've read the problem carefully, and now our duty is to describe or identify in words the quantity or the quantities. We don't know yet if it's just one thing they're asking us to find or two. You are being asked to find. So just in words, give me one thing we're being asked to find. One thing. Yep. It's Orlando, right? Yes. Yeah, Orlando? Right, the average salary of an American. I actually don't like that language because it's a U.S. person. Americans are both North and Latin, South America. Salary of a U.S. person with a, what did you say, master's degree? Master's degree, all right. Are we asked to find anything else? What else are we asked to find? Right, the average salary. So all I'm doing is identifying what I'm being asked to find. That's my first step with a bachelor's degree. Okay, that's my first step. Now is where the algebra comes in. You need to then look in the story for a relationship between these two things. And one of them is going to be given the assignment of a variable. We can call it x in this case. And then the other one is going to be described in terms of that. So we go back to our original sentence, the very first sentence, and when it says that if your master's, the salary, the average yearly salary when you have a master's degree is, and they're talking about the master's degree in terms of how it relates to the bachelor's degree. So the master's degree is being described as some type of expression that depends on your bachelor's degree. So you let your bachelor's degree be your X. So X is the average yearly salary of blah, blah, blah that has of a U.S. person with a bachelor's. Now, I could have defined it the other way, but it's just much easier in terms of how the story is written to have the bachelor's degree be X. Okay. Now, is the average salary, yearly salary with the master's degree going to be a bigger number than this? Is it a bigger amount from your story? Yeah. So you're going to be adding something to this or multiplying this by something, subtracting. So what you have to do is you have to then go back and say, well, what is the master's, the yearly average yearly salary for masters? It's $49,000 less than, we know we need a subtraction here, twice the amount of the bachelor's. So we take the bachelor's amount, we double it, and we subtract 49. Now the question is, notice it doesn't say 49,0000 because your units are thousands. So you just write 49 because that represents 1,000. Okay. Now the reason I'm doing it this way is so that I can use the language of the first sentence to create my second expression. If I say X is the master's degree, then I got to figure out what do I do with the bachelor's degree? Do I have to add 49 to it and then divide by 2? I mean, I don't know what I got to do. It's too confusing. So because one is already described to you in terms of the bachelor's, that's how you begin to identify your two expressions. Brendan?
The way it was worded, it sounded like you take 49 from X, then multiply.
I know how it may sound, but you have to think of the price of the master's degree. You got to kind of, So let's see. Did I do it right? I'm going exactly like it says. So here's a master's degree. The amount of money, it's bigger, right, than this. The average salary of the master's degree is $49,000 less than twice. But you may be right, Brendan. I could be wrong. So how would you sort of do this? Here's another little strategy. Pick some numbers. See what you would do to the numbers, and that's what the algebra does. So let's just pick some easy numbers. So here's $10,000, right? If I was following this, how much would the master's person make? Well, I got to make it a little bit higher. Let's make this 40,000, right? So this is how much I would make from having a bachelor's degree, a BA, say. How much would I make if I had a master's? Twice that, right? So my master's degree would be twice that, 80,000. What? Minus 49. So, did I do it right? No. And this is part of the problem. Sometimes we think of math as a translation, like if we were translating a sentence from English to Spanish or vice versa, we take the words and we try to find the appropriate symbol for them. But in mathematics, you're dealing with a variable that represents a quantity. The master's degree represents a quantity that's twice as big as the bachelor's, minus 49. All right, so how am I going to write that? Is this true? If I take my bachelor's degree and I double it and then I subtract 29, is that the master's degree? Excuse me, 49. Is that right? Now I got you really confused, don't I? Yeah. So that wouldn't make sense, would it?
It says up there, 49,000.
Yeah. Where do I subtract the 49,000 from? I could do two equations, two variables here, and then that would be a little helpful, right? Maybe. What do the two add up to, though? We don't know, right? Combine two people's right each. All right, so let's try it that way. That might be our final equation. All right. All right, so let's try it with two variables, but we got to come back to this idea. Assign a variable, so I'm kind of skipping ahead here. Assign a variable to one of your unknown quantities. So let's just do it this way. Here, let's take this out altogether. Here, I'm skipping ahead. I've assigned a variable to represent the average yearly salary of the bachelor's degree. Okay, we all set there? I've assigned one variable to that. Write all other unknown quantities in terms of this variable, because your book is using one variable, not two. You'll notice when you read the book. Okay, so is it Andrew? So Andrew said, I snuck in and used another variable, and that's okay. We can do it both ways. So let's try it this way. Okay, we're going to divide this up. One variable, because we still got to figure out how to represent the average yearly salary of the master's degree. One variable or two variables, okay? So if we're going to use two variables, we introduce a new variable called y. And what does y represent? Y represents the average yearly salary, blah, 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 when you have a master's degree. Okay. And we still haven't settled on the one variable yet, but we'll get there. Now, what's equal to what here? Well, if you're going to introduce two variables, you need to come up with two equations. You have to have two what equal what's. So your first what equals what is that if you put these two salaries together, they're going to earn 116,000. So the average annual salary from your bachelor's degree plus the average annual salary from your master's degree is going to equal 116,000. But I can't solve that equation. I need other information. Okay, the other information is this relationship right here between the two degrees. And that's what helps you figure out how to establish this other variable. We can't solve that equation without some more information. Okay, so we're still stuck. How do I represent the other unknown variable, which is the average amount, the average yearly salary when you make a master's, when you have a master's degree? What is it? How do I represent it? I know it's going to be twice X, but what do I do with that 49,000? Where does it go? Yeah, but we still got to figure it out to solve it. Curtis?
First, I made two equations.
No, I'm sticking with the one right now, right here. How do I represent the yearly salary with the master's, Nathan? Well, that's what we had, so let's try that. Oh, so you think it's two parentheses X minus 49. Interesting. So do I first subtract the 49,000 and then double it? Well, the only way we're going to find out is let's try solving the problem with these two things and see if our answer makes sense. So we're not quite sure. Is it this or is it this? We're not quite sure what it is. So let's try it. We know that if we take our salary from our bachelor's degree and we add the salary from our master's degree, and we're not sure which one it is just yet. We're going to try to figure this out together. So let's try Nathan's idea. We know we're going to get $116,000 when you add those two salaries together, those two average salaries. So let's solve this equation and see what we get. If you add 98 to that, and if you divide 214 by 3, what do we get? 71 point something for your bachelor's. That seems a little high, right? So let's try the other way. X plus 2x minus 49 equals 116. 3x minus 49 equals 116. 3x equals, now add 49 to that, what do you get? 167. X equals, 3 goes into that 5 times 50. Oh, thank you. Yeah, that's a lot nicer. 55. So now we're saying that if you have a bachelor's degree, you earn, on average, you earn 55,000. So how much would you earn if you had a master's? It says to subtract 49,000 from that and then double it. So let's see if that works. 55 minus 49 equals 6. It's 2x, right? Okay. I'm making sure you're following me. So we're saying this is how much you make right here if you have a master's, right? So double it and then subtract 49. 110 minus 49 is 61. So that works. 55 and 61 is 116. Okay. Well, I was just picking numbers here. I started off showing you the correct way. Brendan thought it was wrong, so then I went with what Brendan was showing you, and we couldn't get anywhere, right? All right. This says that if you double your bachelor's, the amount you make with your bachelor's, it would have been a lot nicer to just say, hey, if you earn a master's, you earn twice as much money as a bachelor's. But it isn't. It's twice as much minus 49,000. It's not that much more, but it is a little more, okay? Now, the reason we couldn't use this idea, which Andrew brought up, is we would still have to be able to describe X and Y in terms of the other one. So now you would have had to be able to say Y is 2X minus, 2X minus 48. So you could substitute, okay?
Yeah, that's what I was talking
Right,
about.
right.
You sort of did use what I did.
Right, right. Okay. So if you wanted to use two variables, you would have still had to say 2x minus 48 somewhere away in the problem. Okay. So sometimes the language is almost verbatim. Sometimes you have to think about the fact that you have two variables, which one is larger. In this case, it just says, hey, look, if I double my bachelor's salary, my master's salary is equal to that minus 48,000. It really isn't as tricky as we were trying to make it to be. All right. So then you write a sentence with these two final things. The average annual salary of a bachelor's is 55,000. The average annual salary is 61,000. Okay. So try the next one. Let's try the next one. See if you can get down these first three rows yourself, and then we'll go together. This is the key right here. Read your story. You should be familiar with this. It's a texting plan. Let's take a look at this together. So you read the problem, and now just describe in words. That's all. I just want you to describe in words the quantity of quantities you are being asked to find. How many quantities are you being asked to find here? Find out how many text messages will the cost for the two plans be the same. So you want to know how many text messages for plan A and how many text messages for plan B, right? So the number of text messages if you're under Plan A. Oh, I haven't right. Sorry. I froze it for a reason, but let's see. Where's the unfreeze? There we go. Okay, number of text messages Plan A, number of text messages Plan B. That's it. You're just establishing what you're being asked to find. Okay? All right. But isn't that number of text messages going to be the same in the end when you find it? Okay. So you really only need to establish one variable here. It's the number of text messages. X is the number of text messages under both plans. The cost will be the same. Okay. So is this correct, what you're asked to find?
Yes, it is.
Okay. Assign a variable to one of the unknown quantities. X is the number of text messages, either under Plan A or Plan B. So write all other quantities in terms of this. Okay, so the cost is the cost under Plan A and the cost under Plan B. Notice I used a little subscript. Are the two things, other quantities we need to find. How do I establish the cost under Plan A? Well, I have to write an equation. I have to finish the equation. Under Plan A, it starts off with 20 buckaroos. And then what? It's 5 cents per text message. So it's going to be 5 cents per message times the number of messages. And the cost under Plan B is $5 plus 0.10x. You like buckaroos? Okay. All right, so what is equal to what here? Find how many text messages will the cost for the two, that's kind of a weird, find out, I must have written this when I was like half asleep. Find how many text messages will the cost for the two plans that will make, I guess should be, will make the cost, should be in there, for the two plans the same. So what is our equation here, Orlando? Right, when are the costs the same? Here we go. And then we substitute, as Orlando said, each one of these in for the cost, because those are the two expressions that are equal. So 20 plus 0.05x is equal to 5 plus 0.10x. When are those two costs the same? And now you solve the equation using the properties of equality that you've used over and over again. So I'm going to subtract 5 from both sides. 15 plus 0.05x equals 0.10x. Then I'm going to subtract 0.05x from both sides. 15 equals 0.05x. And then I divide both sides by 0.05x. Excuse me, by 0.05. And what's my answer? 75, is that right? Can't be point. 15 divided by 0.05. Oops, shoot, second quit. 15 divided by 0.05. First of all, folks, you know, you gotta have some mental math going on before you use your calculator. 0.05 is like what coin? A nickel. This says how many nickels are in 15 bucks? That's what it says. Well, how many nickels are in each buck? 20. So you got 15 times 20. Okay? And you should be able to at least get a sense that your answer can't be a decimal. Okay? Can't be point anything. Okay? You're putting a really small quantity into a larger quantity. This is an improper fraction. This is math 090 stuff. Your answer has to be bigger than 1. Okay, try to use something other than the calculator pads so you have a sense of whether what you're doing makes any sense at all. Okay, so it says 300 text messages. So there you go. 300 text messages. Check your answer using the original wording of the problem, not the equation you obtained. So if I take $20 and I have 5 cents per text message and I send 300 text messages, let's see what that gives me. 0.05 times 300 equals 15 bucks. Then I add my monthly fee. That's 35. Now I do my other plan. $5 plus 10 cents times $30 is 5 plus 30, which is 35. Yoo-hoo! They work. Yay! One side equals the other. And then you write your sentence. You can all write a sentence. Remember, a full sentence when you write it has a subject and a verb. Okay, so I don't want to just see 300 text messages. That's not a full sentence. Okay. So those are the steps you go through. Does that seem doable? You just follow what the information, again, you establish what your variable is. X is the number of text messages used in both plans. Okay. Any questions on that before we move along? Anything? All right. All right, so let's see how our calculator could have given us those same answers, okay? So if you pull out your calculator, I've asked you to bring your calculator to class every day. So please bring it out. And let's see how we can use our graphing calculators, because sometimes you want to be able to check what you're doing and have a sense of what you're doing. So our monthly cost under Plan A, we said, was 20 plus 5 cents a text. Yep. And our monthly cost under Plan B was $5 plus 10 cents a text. So we're going to put this first expression into Y1 and the second expression into Y2. So if you're not bringing calculators to class, you're not going to be learning these steps for your homework and for your quizzes. Okay? You're going to be at a disadvantage. Okay, now it says display the table results. The question is, now we have a context to our story. Where are we going to start our table? Are we going to start our table in negative numbers? No, we can't have negative text messages. So we're going to start our table. So we set our table, second window. Okay, our table, in fact, we can start it at 0 if we want. We look over here at this table, and what are the increments? 50, right? So we can say 0, we're going to increment by 50 messages, and I want it to automatically calculate each of the costs. So I have auto turned on, and I hit second table. Okay, so I go down to my third one at 100 text messages. My first plan is more expensive than my second plan. At 150, it's $27.50, and the next one is $15. Okay, the first one was 25 and 10. Sorry, I read it wrong. Oh, I'm reading this wrong. Hang on. My eyes are going to the wrong column. I had it right. 15. Maybe you can help me. 20. And then what is it for 200? What's the cost of the first plan? 30. Thank you, Tiffany. And the second plan? Thank you. 250. Someone else? $32.50. Yeah. And 300. We know is 35 and 35. We don't have to go any further. That's where our table tells us that our two plans cost the same. Okay, right there at 300. So notice your table verifies what you're doing. And now how would you do it graphically? Well, here's where you want to set your window. We don't need to set our window in negative numbers. We could start at 0. And we can go, we know from here we only need to go up to 300. But at the time that I set my window, I didn't know what the answer was. I hadn't done the math. So I just said 0 to 500 texts. And I had to increment by 10. I didn't know what the maximum cost was going to be, my Y, so I just said $50. I didn't know. And then I just did second table, whoops, no, graph, and there it is. There's my first equation, and there's my second equation. So notice until you get to the point 300, this intersection point right here represents, I have to take a picture because I can't write on my graphing calculator, so let me take a picture of this. Okay, so this intersection point, which you can find with your graphing calculator, if you want, you just put in intersection and it will tell you that, but we already know the answer from doing all the math. So this point right here, at 300 messages, it's $35. And what this graph tells you is prior to 300 messages, if you send less than 300 text messages a month, you're definitely going to go with the second plan because the cost is smaller. If you send more than 300 text messages a month, after that, the first plan has a cheaper cost. Okay? So this is a way of comparing two separate plans, finding at what point they're equal, so that depending on how many text messages you send a month, you would know which plan to use. Now, I don't send 300 text messages a month, but I know some of you send thousands, right? Probably. All right. Or maybe, I don't know. A lot of the plans are unlimited now, right? But I had to put a $10 plan on one of my kids' phones for 1,000, right? And my other kid, my oldest daughter, doesn't use texting at all. She doesn't like to text. So, you know, each to their own. All right, so that's a couple of the word problems. Let's go through one more. I'm going to save this one. I want you guys to get working on your worksheet for a while because I've been doing this for a while, talking to you. So start number 1 on your worksheet. After you have some time to work together and work through that, we're going to go back to the other type of word story. Let's take a look. Read the final phrase. What is the final phrase of this story opportunity? What is the dealer's cost of the refrigerator? So I take that dealer's cost in dollars of the refrigerator. I write it out in words. That's step 1. I assign a variable to it. I saw a lot of you put D, so I'm going to use D just to have a little variety. Okay, I've established my unknown that I'm trying to find. I've defined it. I've defined it as a numerical quantity with a unit. Boy, I've done those first 3. Perfect. The next part is establishing what is equal to what. Well, you see at $584 in this problem, something is equal to that 584. What is equal to that 584? How about just in words first? Just in words. The dealer's, the price of the cost to the dealer, right? So here's a big bag of money. And this represents the dealer's cost. What do I add to that dealer's cost? 0.25? Does that make sense? I add a quarter to it? No. You don't just put the percentage down with nothing after it. What are you doing with that 0.25? What is it? What are you taking 25% of? This, right? The dealer's cost. You're taking all of that dealer's cost and you're adding a little bit more, right? You can maybe divide this into 4 equal parts, take out a chunk and add it to it. You're taking 25% more of this thing. So you're taking 25% more of that bag that represents all the money in there called the dealer's cost. What are we going to replace this bag with? D. D plus 0.25D, I mark up the price as $584. 100% of D is right there. That's what that 1 means. All of the dealer's cost plus a little piece more gives me 1.25 times D equals 584. I know D has to be smaller than 584. So when I divide it by 1.25, my number is going to get smaller. And what did you get? For what? 467 and 20.2. Don't put the dollars on D. D is just the number. The units come after. So the dealer's cost in your sentence is, now put the $sign on, 467.20. Boom, you're done. Now, let's go back to the dual investment problem right here. This is where, notice right below this problem, number 5, I have a table. A lot of students really like these tables for the story opportunities. And this is where Andrew's idea of using a second variable comes in. I really like using 2 variables here. Your book will show you how to do it with 1 variable. So when we started math, say 106 or 096 off, we would do these problems with 1 variable, and then we would end up doing them with 2. So let's do them with 2 variables. I think it's a lot easier. So we got 2 investments here. We got a scholarship fund, okay? And it has $10,000 in it. That's in the whole fund, the scholarship fund. Now what we're going to do is we're going to take that $10,000 and we're going to invest it into 2 different funds. All right? One of the funds has an annual interest return of 4% and the other one has 8%. So I have to establish in words what I'm going to be asked to find. So hopefully somewhere in the story there's a sentence that tells you what to find or a question. How much should we invest in each fund? So you start off by saying the amount in dollars invested in the low risk fund. I'm just doing my words. And what's the other one? The amount in dollars invested in the higher risk fund. Okay? I'm not trying to do this problem all at once with this equations and all these variables. I'm just taking a breath. Okay? Now, again, your book will show you, please read your book, how you can do this with 1 variable. I'm going to show you with 2. So we're going to call this first one X and the second one Y. Now, there's another idea in this problem, which is the amount of interest you get from each one of these funds. So you really have 4 descriptions you have to write. Here's your other 2. The amount in dollars of interest earned on the X dollars invested in the lower risk fund. You might say, I'm not going to write all that out. She's got to be kidding me. Well, if you can write it out, then you understand the problem. So how much interest did I earn on X dollars in my low risk fund? 4% of X dollars. So I write that by 0.04x. That represents the interest. What's the mistake students make? They put things like 0.04. That has no meaning. It's just a number, 4/100ths or 4 cents. It means nothing. Okay? So you've got to multiply that by something, and you're multiplying it by the amount you put in the low risk fund. What would my other variable expression look like that I would need to solve this? Yeah, Eric? Yep. Yep, on Y dollars invested in the higher risk fund, right. Okay. You can use those little quote marks so that you have to write too much. And what would be the variable amount, that the variable expression that would represent that? Someone other than Eric? What would represent that? Yeah, Andrew? I'm sorry, Ian? 0.08y. 2 different ideas. This first block up here, right here, just represents the amount of money you have. This just represents the amount of money. That's it. The second block represents the amount of what? Earned interest. 2 different ideas. And guess what? You know 2 what equal what's now. You know how much that first red block equals. How much money did you invest? Or how much money did you have to start with? 10,000 bucks. So what kind of equation can I get? Well, the amount in my first that I put in my low risk fund plus the amount I put in my high risk fund is $10,000. Okay, that's my first what equals what. Now I need a what equals what about the interest. Do I know a total interest amount here? Oh yeah, I get $550 interest from both of these. So the interest I earn on my first account plus the interest I earn on my second account is 550 bucks. This is called a system of equations. So if you solve your first equation for either x or y, for example, y equals 10,000 minus x, this is how your book shows you how to do it with one variable. Instead of using a y, you would use 10,000 minus x. Then you solve this equation, your second equation, by where you see the y, you replace it with the 10,000 minus x. So then you solve your equation, 0.04x plus 0.08. Now instead of y, you replace it with what's left over. You have $10,000 minus x. That's what y would represent. And that equals 550. And then you solve this equation, 0.04x. 10,000 times 0.08 means you move the decimal point 1, 2, 3, 4 zeros. You move it 4 places to the right. So that would become 800 minus 0.08x equals 550. You put your like terms together, you get negative 0.04x plus 800 equals 550. Subtract 800 from both sides. 0.04x equals 250, negative 250. Negative 0.04x equals negative 250. Now you take out your handy dandy little calculators and you say 250, because I'm going to be dividing by negatives, so that's just like positive 0.04. You expect a much bigger number than 250 because you're saying how many 4 cents go into 250 bucks? $6,250 is how much I would put in my lower risk fund, and then y is equal to $10,000 minus this amount, which is what? $37.50, right? And then you write your sentence. Okay. So this table helps you organize everything we just wrote in words. If you put down your lower rate investment and your higher rate and the amount invested in each, you can just say X and Y. And notice your last row here is your total, 10,000. So if you come straight down your column, there's your first equation right there. X plus Y is 10,000. Boom. No, I'm saying you should have a table on your sheet. Okay. The percent interest is, all you're doing here is writing down the different percent interests. That's it. So there's nothing down in this. There's no multiplication. You're just saying 4% and 8%. And then when you multiply these two across, you get your amount of interest on each investment. And then when you add those two columns, those two rows, right down the column, you get your 550. And there's your second equation to solve. And we've just solved it. So some students really like this table. I would recommend it when you're doing these dual investment problems. So try this on now your second group exercise that I gave you right under the dealer's cost. Try to use, you can use set up the table. I'll help you set up the table if you want. There's a problem very similar to this on your group exercises.